Today I want to do a framework code review, and I think that this is actually something really special. I don't think that this is something you would usually see people doing something this in-depth. However, I think that this could be interesting to some of you. It is certainly interesting to me. What we are going to take a look at is, what is build context? Like, what actually is it? You will have seen it a lot, but what is it? And spoiler, it's closely connected to Element, so we're also going to take a look at Element. And in particular, we're going to take a look at these two classes in the framework.dart file. So this is why it's a framework code review, right? Because it's in the framework.dart file in the Flutter framework. It's really going to be low level. So here, a quick disclaimer. This is not going to be something practical, something that you will use in your everyday Flutter app. However, I think that I will be able to give you some insights into how the Flutter framework works, because I'm going to show you a bit of how the build context and with that, the element works, what it really is. So let's just get right into it and take a look at build context. It says that it's an abstract class, but they're just classes that implement it. We can see it here. The element class implements it, but there are no actual subclasses. In fact, we can look for it, right? There are none. And if we look for implements, we will find one, and we will find another one, the null build context, which is only a task class. Okay, so this doesn't count. It does not count, it's a task class. You can see it, it's in the widgets test. So it's in the tests widgets. So that's why it's marked green here. So we don't count this one. So it's really, there's just one class, it's the element class implementing it. And this also means that, strictly speaking, this is only an interface. So this should be called interface. But it's not, because in Dart there is no interface keyword. An abstract class is an interface in Dart. That's just how it works. And if you're coming from another programming language, you might be more comfortable with the term interface, and it really is just an interface. And this is the beauty of it. Because if we take a look at it, Element implements build context, and it's the only class implementing build context. So now we can infer that every time we see a build context in our app, and we see build context a lot in Flutter, that means we always have an element, because that's the only class implementing it. So that's amazing, isn't it? If we take a look at this example, where I have hooked up an experimentation widget, and the only thing this does is provide us with an experiment method that takes a build context, and this experimentation widget is really simple. It just takes a child and it returns the child, but also runs our experiment method. I purposefully use the stateless widget because that's probably what most people are familiar with, and it's really not low level. But I want to show you that we can even use a stateless widget, which is obviously not intended for any element tree shenanigans. We can even use this to access the element, because as we just found out, a build context isn't really a thing, it's just an interface. And this means that if we are going to print the runtime type of this context, it's going to be an element. Before we're going to do that, let's take a look at the element subclasses here. And let's take a guess which element we're going to see when we print the runtime type of our stateless widget build context, right? There are quite a few element subclasses. Let's search. Oh, right. There we go. We're probably going to see a stateless element, which exists. We can take a look, and it's really simple. It's really simple, right? It's just an element that uses a stateless widget, and then it provides the build method of the component element, which we're going to take a look at in a second, and it also has an update. method. So it's really simple because there's really nothing it needs to do. So we run it. What do we see? We do see stateless element. Let's just ignore the error here. We do see stateless element being printed for our runtime type, which is what we wanted to see. Let's see if we can remove that. Yeah, there we go. We see the stateless element. So our runtime type of the build context here is actually stateless element. It's not build context, of course not, because that's just an interface. And before we dive deeper into component elements and stuff like that, we should really take a deeper look into the build context. What does it mean to be an interface? Right? That is really, I think it's such a great design decision, actually, to create this interface of the build context, because it allows to expose an object, the element in that case. The stateless element is also an element, and the element has all the control, right? It's really, you always have this element at your disposal when you're just in a build method, and you could do anything with it. And I think that's the beauty of this design decision. It's that you always have the element, but you can pass it to the user, to anyone using the framework, because you have this interface in between. So they will only ever use the members on this interface, right? The methods that are defined here on the context, instead of maybe completely screwing up the element tree, which is, I think it's so smart. And if we take a look at it, there's some really simple stuff. For example, we can see that a widget, in this case, is just the configuration of an element. And you probably have never done this, but you can get the widget from the context. And if we take a look at it, we will get our experimentation widget from the context here. And this means that we can obviously also get the child, which would be the column. We can't do child here because we don't know the type yet, but obviously we know that our widget is the experimentation widget. So we can cast that, and then we can take a look at the child. And indeed, it's a column. And we could even go as far as looking into the children of the column. But let's just not do that. Just be aware that a widget, going back to the trees, you might have heard about the element tree and the widget tree. I'll just pull that up quickly. So there we go, I found an example. Here you would see the trees. Obviously, this is just 3 nodes in the element tree. And there's always a widget associated with an element, which means that the widget is just the configuration of the element. And this is actually really, I think it's so intuitive. You're saying with a widget, you have some parameters. For example, for a text widget, you have the content of the text, right? The text, you have the text parameter. And this means the configuration of that element, of the text element, is you have this text, and that is what it should do. And then the element, or write whatever you implement, for example, with the build method in your stateless widget, it will deal with what to do with that configuration. If you have a stateful widget, you will know that you have access to the widget, but that might change in your state. And about configuration, I think that's also the moment where we can take a look at the component element, because that's really what is the configuration element in that case. It might not be the best explanation, but it's very simple, right? An element that uses a given widget as its configuration. This means that I would almost call it a proxy, because it doesn't have a render object associated with it. If we take a look at this image again, there are some elements that also have render objects. So in that case, that part of the tree would render something to the scene. However, a component doesn't render to the scene. It's just a proxy. It just has some configuration, and it passes that configuration, that widget, on to its child, right? Because, for example, in this example, it's a nice example where we have a text. This text, we can just take a look at the implementation of the text widget. It's just a stateless widget. It just takes the configuration that we have in here, and it just passes it on to a rich text. And the rich text is a render object widget, which means that the rich text is going to render. However, the text is just an element. It's just a proxy. It just has some configuration. And that's why I would call the component element a proxy, where it's really just about having the configuration and passing it on to another element that's going to do the rendering. Obviously, you can do some more shenanigans with it. When you have the component, you can do some more shenanigans. But I would call it a proxy. And this is also why stateless widgets or stateless elements are component elements. However, stateful elements will expand it a bit. Again, stateful elements, if you have a stateful widget, it's still not rendering anything. It will just pass whatever you store in that state, and the configuration, like the state depends on the configuration, it will just pass it on to another element that might do rendering. I hope now the configuration, like the widget as a configuration part, is somewhat clear. We will probably go into it a bit more when looking into mounting. Then the next thing is the build owner. This is really nothing you would usually encounter, I think. So here it just says it's an object that manages widgets. I mean, you can look into it, but I would say it's not that interesting in our case because it's nothing you would usually encounter. So I'm actually not quite sure why they exposed it for widgets, but I guess it's definitely, it has uses, right? They call it the manager class, but it's definitely nothing that most people encounter. I have certainly not seen any example where someone accesses the build owner using a context, but it's whatever. You could always just cast your build context to an element and then access everything on the element. So maybe it would have actually been wise to just hide this from the interface, but it also doesn't hurt. I guess it's useful in some way. The next thing is debug doing build, which is interesting. Let's take a look whether the widget is currently updating the widget or render tree. And that's really useful for something like provider, because you can't do certain things while, as it says, while updating the widget or rendering. Updating the widget would be in the build method. That would be updating the widget. So if we print debug doing build, it will say true because we're updating the widget in the build function. And it also means that some other stuff is not yet initialized. For example, the next one, find render object, it will be null. Oh, actually, there's already a render flex attached. Okay. But it won't have a size, but I guess it will throw an assertion. Yeah. So it won't even return anything. So I guess I don't really have a good way of demonstrating this, but the build method is updating the widget, which is also why it was true. And this is really useful for something like provider. I think Remy used it a lot for assertions. So this is what you will use in assertions. It's not something that you will use in production code. It's obviously debug. It's a debug thing. It's a debugging thing. But it's definitely useful because some things you just cannot do in certain states of the life cycle, and this is useful for checking that. Like if you see where it's set, for example, okay, this is in tests anyway. Let's see which one would be the local one, private one, debug during build. Yeah, so it's something that's only used during debugging, which is also why it's like in debug mode. It's only used in debug mode. That's why it's in an assertion. It's set to true and then to false again. And this basically ensures that anything that happens in build, which is why it's called debug during build, should not, like you can assert that this is false when you don't want something to happen in build, because certain actions cannot be. I think it's obvious what it does. The render object, this is pretty obvious. If we look at the tree, we want to find our render object. Let's see which one it will return. Okay, the first descendant. So basically, if we take a look at the tree, if we have the align widget, it will return the position box. If we have the text widget, it will return the paragraph. Because the text widget, it does not have a render object, but because we find the render object, here again, this is a smart design decision where we don't have a property for the render object. It's a method instead. We can also return the descendant, which is obviously more useful in the case of a proxy or a component element for that sake. I just like to call it proxy because, I don't know, it fits nicely. But I think component is actually really fitting because that's what it is. Anyway, size. This is a beautiful one again. It's because it's just a shortcut. If you think about it, how do you get the size of a widget? Of a context, sorry, of an element in that case. Build context, obviously the interface for an element. So how do you get the size of an element? Obviously, an element itself doesn't have any size. So what does have a size? A render object. The part that is being rendered has a size. So this will obviously just be a redirect to find render object and then the size. And then not every render object has a size because the concept of a size only exists in a box. If you have a sliver, for example, that doesn't exist, which means that the size will only be returned for render boxes. And if we take a look at the implementation, you will also see, okay, if it's a render box, it will return the size, and otherwise null, because there is no size. For example, for slivers, there cannot be a size. This really depends on, for example, you could just work around that and create your own render object that doesn't use the render box contract, and then you don't have a size anymore. So this is just a neat shortcut. And again, this really shows what build context is. It isn't anything, it's just an interface. The next few methods, you might know them. The ones you probably use if you ever used inherited widgets. So when I started with Flutter, it was kind of common to use inherited widgets. But nowadays, no one uses them anymore because there are further abstractions built around them. For example, Provider is a great abstraction around inherited widgets. I would say the best one. It's really nice, which means that you don't have to worry about it anymore. If you use Navigator, let's say Navigator, there is a Navigator of context. Let's see, let's find it. This is obviously inefficient, but it's fine. Here we have a Navigator of context. it will return a navigator state. Why? Because it uses, as you can see here, it finds the ancestor state of type, which is actually here. Here you can see it. Finds the ancestor state. This is where you will still see it. Obviously, if you look into provider, you will see it. But what you would do with inherited widgets, you would actually call these on the context. Like depend on inherited widget of exact type, for example. These are really common. It's all the same pattern, right? Inherit from element, depend on inherited element. These ones you wouldn't use in the widget tree because you would not access elements directly. You would use these ones or the ancestor state ones. Ancestor state is actually something that is probably still used a lot because it's pretty useful. Still, even if you have an abstraction like provider, ancestor state is just so direct that I think it's still used a lot manually. If we take a look into the implementations of these, whoops. I know it's not the most efficient way, but if we take a look into it, it actually just checks the parent, which we will see in a second. And then it checks if we have a stateful element and the type is matched, and then return that. This will, if we take a look at this loop, it will basically, it will just throw if it doesn't find it, because it will go through all ancestors, it will go through the root, and if it doesn't find one that matches the type you pass, then it will be a typecast error. But I think it's pretty obvious. You just go up the, okay, let's see it from here. Let's say you're in the rich text and you say find ancestor state. What is a state? A state is just an element. It's just another abstraction where you have your state class that basically is just built around the stateful element. So what do? You look up the element tree and you will find, right, at some point you want to find an align state. I don't know. Does it even exist? Probably not. Because it's the render object widget, you won't find it. But let's say there was another widget, your custom widget, and you would try to find it, so you go up the element tree. Actually, let's consider the case where you don't find it. So you have a custom widget, it's called my custom state. Your state is called that, and then you want to find it, so you go up. You check the element, and you want to check if it's a stateful element, because, as I said, that's the abstraction of the state. And if you find it, you would return it. In that case, the root would be the align, and that sadly isn't a stateful element, so that would crash. But otherwise, if you find it, you would get the state, which is, in that case, a stateful element has a state, which, as I said, is that abstraction. As you can see, state has the state, and actually they're interlinked because the stateful element has a state member and the state has a context member, and the context obviously just returns the element. It's just a cast here, right? Or this, you don't need a cast because BuildContext, like the stateful element obviously implements BuildContext. You can just return that. And here again, you can see the beautiful design pattern. What you have is you have an interlinked, right? The interlinked dependency where the stateful element has the state, and the state also has the stateful element. But what is exposed to the user is not the element, it's the build context. Again, we only have the interface. In this class, we have access to the element, but when someone uses a state, when you use a state in your Flutter app, you will never see the element, you will only see the interface, the build context, which is pretty neat. So yeah, I think it's rather obvious how that works. If you look at depend on inherited element, that's another contract again. Right. As you can see, it's just a hash set of dependencies, and then that has some logic around it, how the dependencies work. And that's also how provider, for example, works. It just depends on it depends on the element, and that will trigger, it will trigger marking it dirty, etc., which is pretty neat. Obviously, this is very basic what happens in the dependency. The complicated logic is then working with the dependencies. I don't think we need to look at all of them. They are very similar, right? Where we have I don't think there's I mean there's a lot to say, but I think it's not that interesting for looking at the build context and element relationship, because this is more looking into how dependencies work in Flutter, which I think is also really interesting. In fact, it's something that's especially interesting if you write. Let's at least take a little look at it. If we have a state, it will have its it did change dependencies, and essentially did change dependencies works with inherited widgets. What is an inherited widget? It's a proxy widget, and this is also why I said that component element is what I would call a proxy element, because there is a proxy widget, in fact. But that's just a widget. Give me a second. Let's find the corresponding element. We can't find it here, and it's probably not linked in the documentation. No, it's not. So we have to go back to our element. And the inherited element is what we have for the inherited widget. That's, as you can see, the element that uses an inherited widget configuration. And now you can probably already see the dependency relationship and why I said this is all the same, right? Inherit from element, depend on inherited element, inherit from depend on inherited widget, because the widget is the configuration and the element is really the underlying part in the element tree, where the configuration, it's strictly speaking, the real tree is the element tree, and the widgets as the configurations are just attached to it, right? So this is how the dependencies work. There's all the dependency stuff around this. Yeah. I'm thinking about how deep I want to go into this, but I think I want to quit because there's a lot to say. I think what's really interesting for users of did change dependencies. So this is really the contract in Flutter, where if you have an inherited widget and you look up its configuration or the data that's saved in it better. So essentially the data that's saved with the element. If you look that up, you mark yourself as depending on that element, depending on that inherited widget. And by depending on it, anytime that inherited widget marks a change, we look at inherited widget again, where an update should notify. So anytime this inherited widget notifies, any dependents will be notified and they will rebuild. And that's the whole contract. That's like the whole concept of provider, basically. I'm not sure if provider even uses inherited widgets still, but it's definitely that context. It might have its own elements. I'm not exactly sure. It's been a while since I looked into that. Yeah. I think that's probably enough information. It's the whole dependency contract is what really powered looking up information where you declare yourself as a dependent, and any dependency will trigger did change dependencies. And that's how your widget rebuilds when you call theme.offContext. Anytime you use that in your build method, you will, for example, you look up a color, but when you change the theme, your widget will update. And how does that work? Basically, anytime you call, you depend on an inherited widget of exact type in your build method, for example, theme.off, you will have a depend on inherited widget of exact type, as I said. Anytime you call that in your build method, you will declare yourself as a dependent on the inherited theme widget, right? Inherited theme is an inherited widget. So anytime you call theme.offContext, for example, to set a color in your app, you declare yourself a dependent of this inherited widget, of this inherited theme. And this means that when the theme changes, right, when it notifies about a change, your widget will also update because you declared yourself a dependent and you have this dependency. And that's this really beautiful contract in Flutter. Okay, next thing is with visiting ancestor elements and child elements. Actually, ancestor elements is really straightforward because when we take a look at the element, we can just start doing that now. An element always has a parent member, and that parent is set up during mounting. As you can see, yikes. So you can see during, okay, I guess inflating. Anyway. I guess during mounting, yeah. So the parent is set during mounting, what I said. Anyway, that parent is always set. The only case it would not be set, of course, is when you have the root element, because your root element does not have a parent. And that also means that visiting ancestor elements will be really easy. And this is just, again, we have the BuildContext interface that this is just for ease of use, and obviously also exposing it because this is a private member. Visiting child elements is way more interesting, and we will get into that, because if you look here, an element does not declare any children. There are no children here. The only thing you will see is visit children. There is no child in here. The only thing you will see is visit children, as I just said. And the rest of it is just diagnostics. We don't care about it. It's just debugging. This doesn't do anything functionally. Okay. So it's really difficult, and I should have probably made a disclaimer, but I guess it was somewhat obvious that this is all, it's difficult for me to condense this information. I just went over all of the methods and the members in here, and probably, I hope, I gave you some more information. I think the dependency stuff is a bit more like the inheriting. It does make a lot of sense, but it's a bit more complex to explain than the other members. But I hope that I did a good enough job at explaining how BuildContext is just an interface. Now we can take a look at Element and actually take a look at some of the implementation, the actual code review part, where I don't try to explain that much, but actually try to take a look at the code. So we construct an element. How do we do it? We have a widget, and we talked about this before, a widget is only the configuration of an element. But when I said that the element tree is the actual tree, and the widgets are just like attached to it, what I meant with that is even though we construct an element with a widget, where that widget is its configuration, and if you take a look at where it's constructed, it's obviously always in the parent, which means that if we take a look at a stateless widget, we have a createElement function, which will construct the element with this, which is pretty beautiful, right? It's a pretty beautiful contract where we say that we always attach an element to the widget, but in reality, it only happens once, right? If this was called every time a widget was constructed, then we would say the widget tree would be the main tree, but it's not. The documentation says, doesn't say anything about it, I guess, but what it will do is it will create it once and it will set the widget here. However, after that, the createElement method won't be called again. After that, the element will just be updated with the new configuration. So we should be able to see that the widget is reassigned at some point where it's updated with a new, with a new widget. Right, exactly, here we can see it. Exactly what I said. So the element is updated with a new widget. And this is the key. The element tree persists, right? The element tree persists, and it is created with the widget as a configuration, and after that it's just updated. This means that if you have a render color render object, and you have an element for it, right? A render object element, and then you have a widget configuration where you pass the color. The first time the widget is created, it will create the element. But if you change the color, the element will persist and the render object will also persist. But the widget will just be exchanged, where you have a new color. But it will see, okay, the element is the same, and it will reuse that element, it will update it with the new widget, and that is how the widget member is overridden. Which is pretty nice. Pretty nice to think about. Okay, moving on, I already explained the parent one. Then this is pretty interesting. There is a custom equals implementation and optimized for the off pattern. I think it's somewhat weird because like it says that it's optimized. The custom implementation is optimized. But if you take a look at the default equals implementation, it will say that this checks, like the default behavior is to return true if and only if. So yeah, if and only if. If you don't know what it means, if and only if is basically an exclusive if. So it returns true only in this one case, where it's the same object. And identical it's just the same. Checks whether two references are to the same object, right? Are the same object. So I think what we could do here is just do super wait. How do you call super equals? I think you can just do right, super equals other. I think, damn it. I think this is strictly equivalent and should also be optimized. So the override here, I think there is no optimization. The only reason they really override it, as far as I'm concerned, is to make it non-virtual. And if you don't know what a virtual method is, basically virtual means that it can be overridden and non-virtual means that it cannot be overridden. If you're curious, you can always take a look at every annotation and read through what it means. You can always do this, just go into the implementation. It will always refer to some class that doesn't do anything, but it will have some documentation on the meaning. So non-virtual means you shall never override this, and that's, I guess, the optimized part. I'm pretty sure this is strictly equivalent and I guess optimized in the same way, because this is external because the object equal is external and identical is also external, so it's probably the same. Then the same thing for the hash code, and this is pretty neat. Same thing again. They want to make sure that the hash codes are different, so they have the cached hashes, and they just increment it each time, making sure that it doesn't overflow. This is, I looked it up, it's 32 bits, I think. We could look it up, but okay, let's just look it up because now I'm curious. If we go here, we can actually just do print that. It will be, okay, it's 24 bits. So it's 3 bytes. Anyway, that's that. But again, it's non-virtual, so they make sure that it's not overridden. So basically, for every element, you can be sure that it's the identical equals, and that it's this hash code implementation. You can be sure because it's non-virtual annotated, and that means that it's non-virtual. Slot is an interesting one because it's dynamic. I thought about this. Why do they use dynamic instead of using the top type, right? They technically could do this. I'm not exactly sure, but when you would use dynamic versus that top type. But what speaks for dynamic is that this can be anything, right? It's the information set by parent to define where this child fits in its parent-child list. So the parent could do anything with this. It could make this a string, right? If we look at some slot implementations, right, where we have, wait, let's, for example, here the slot would be an index slot, right? Just an example. So it really shows the slots can be anything, which is why it's dynamic. Let's go back to our element. That's also, again, really interesting. Depth is really obvious. Why is it late? Because, okay, let's take a look. Depth just means it's guaranteed to be greater than the parents. Obviously, depth, if you know about trees, you obviously know what depth is. It's just how many levels deep in the tree an element is, a node is. So if this was a tree, which is it's obviously just cut out of context, but the depth here would be 0 or 1, and this would be 2 or 3, right? Greater than 0. The element at the root of the tree must have a depth greater than 0. Yeah, okay. So we could say, for example, depth 1, depth 2, depth 3. And why is it late? Well, because you need to be mounted first to know the depth. That would be my explanation. Let's see where it's set. Yeah, it's set in mount. So as I said, it's late. It's a late int because it's you only know it after mounting, which is also why you assert that it's not in the initial lifecycle state, because in that case it would be in the initial life cycle state, doing the debug assertions, the death would still be unknown because it's not mounted yet. After being mounted, you know the death. And then when your element would be remounted somewhere else, if you reinsert it at some other place in the tree, the death might change, and that's why it's not final. Some stuff like this. Then we have a sort implementation, which this is really curious. So you sort, like, this sorting works by death, and then by whether it's dirty or not. I'm not exactly sure. Like, it's also not documented what the heuristics for this would be. But if you think about it, it makes sense to sort them by death, and then probably by being dirty, because when you find the first dirty one, you would stop. Something like that, right? But it's just some sorting implementation. It obviously depends on where it's used. Okay, why do we sort them when clearing them? Oh, okay, right, exactly. Because we unmount in the reverse order of that. Interesting. Right. Wrong one. I want to go back here. And then again, we have the widget implementation, which we took a look at. When we mount, we attach the widget, or not when we mount. When we update our element, or when the element is created, the owner is during mounting. Yeah, the owner is set during mounting. And then there's just some lifecycle stuff. Right. The next interesting one is the render object, which we will first say visit this, right? We will just visit, actually, we will declare visitor, and the visitor will check if this is a render object element, which we will take a look at in a second, then it will return the render object, and otherwise it will just visit the children. And this is where we first want to look into visiting children. And this is also where the live demo finally comes in. It was really difficult for me to structure this, which is why we didn't use the live demo yet. But visiting the children, that's a really interesting one. So how do we do it? Visit children, it's just abstract. And where are children declared? Because we looked at where the parent is declared, and it's declared in the element, but where are the children declared? Right. If they're abstract, they have to be declared differently for each element. And this makes so much sense. For example, a component element will obviously have one child, right? If we look at the component element, it obviously has a single child, because, as I said, it's just a proxy, so it just returns another element that will do the rendering or whatever, but itself, it just has some configuration. And this means that this visit children implementation, if we take a look at it, it will just call the visitor with its child, and that's it. It doesn't do anything else. And that's so beautiful, because it means that the implementation can be as simple as that for the component element. But if we have for example, if we have a multi-child render object element, right? When we have this, then we have multiple children, which means that we have a list of children, and the visit children method will go through each children. And we even have, for example, we have forgotten children again, where there's a forget child method for elements. So we have a different implementation. This is really, I think, a beautiful design decision again, where the children are not declared on the element itself, but every element has its own chance to implement the children, because some element might just have a single child, for example. Or if we take a look at a leaf render object element, there is no child at all, which means It means that with it, visit, sorry for that. It means that visit children will not be overridden at all. As you can see, there is no visit children here, which means that visit children on a leaf render object element is a no-op. It doesn't do anything, because why would it do? It's a leaf, right? It's a leaf node in the tree, so it doesn't even need to have children. And that's why I think that the children pattern is nicely implemented in elements. So we were at visit children, aka render object. Okay, so what is a render object element? We can get into that. A render object element is an element with a render object that does rendering, and this is cool. This is one of the major elements. I would say component elements, and so we had all the three major elements: component element, render object element, and inherited element. Where inherited, although that was not a nice categorization, because an inherited element is obviously just a component element. Oh, right. So, okay, this is a bit weird. I kind of forgot about the proxy element where I said that a component element is a proxy. Yeah, that's true, but the real proxy element is the proxy element, of course. Right. So much about that. And then there's also proxy boxes for render objects. But I guess in that case, we could say the major ones are really render object element. Right, we can just find them, extends element. So yeah, exactly. Render object element and component element are the two major ones, the two only ones. The two only implementers. So there are two types of elements. There's this kind of element, which is a component, and there's this kind of element, which is a render object element, which draws. So the two types of elements are the ones that draw, and then the ones that just do some configuration that might do some state logic, but that don't draw at all. And that's how the tree works. And that's that's a key. Okay. Do I want to go any deeper? Right, we looked at how retrieving the render object works. And this is just some diagnostics. We looked at the lifecycle, which obviously also is just some diagnostics. I think at least. Would there be any? Maybe there's functional use of the lifecycle states. I doubt it. It looks like this is just diagnostics, so debugging. Visiting child elements. I didn't really explain the pattern. So the pattern is, oh, by the way, this is the visit children is what you have on an element, and visit child element is just renaming this and adding an assertion, by the way. It just renames the visit children method for the BuildContext interface, which is pretty beautiful again. So if you take a look, it's visit child elements is part of BuildContext, right? Part of BuildContext. And it just renames visit children for the BuildContext because it would be out of context to have visit children in a BuildContext, because what is the child of a BuildContext? That doesn't really make sense, but visit child elements makes sense again. But let's talk about the visit children pattern actually, because I didn't talk about it. So the way it works is for every child, there is a visitor, which is just a callback, and this callback is executed for every child. So that's that pattern. Update child, whatever, mounting, yeah, pretty obvious. Yeah, so that's about it. Although activate and deactivate, roughly the equivalent of init, state, and dispose. If we take a look at state, init state, when is it called? it's called in whoops. Actually in first build. Interesting. Shoot. That was not what I wanted to do. But when is first build called anyway? In mount. Okay, interesting. Yeah, I guess not exactly. So actually, it's actually not equivalent. So activate and deactivate is a bit different because it like activate would be when an element is inserted, and activated and deactivate is when it's removed from the tree. So deactivate can be called multiple times, while dispose cannot be called multiple times. Dispose, I suppose, is called on unmount. Let's take a look. Yeah, exactly. So dispose is called on unmount, and init state is called on its mount, and attach and no, not attach, and activate and deactivate, they are different because an element can be activated and deactivated multiple times if you move it around in the element tree. So yeah, it's definitely not. You can't compare it. You can't compare init state and dispose to activate and deactivate. So that was, yeah. Sorry for that, but I think I clarified how it actually works. Sorry for that one. Unmounting, I discussed that now. So mount and unmount is only called once, and mount and unmount is what you can compare to init state and dispose. Bind render object is just, well, I guess again, it's just for the build context. It's this really nice design pattern where we have the build context interface that exposes some stuff that makes sense on an element differently on the build context. Just for reference here again. Just wrapping around it. Here we have all the inheritance stuff. Visiting the ancestor elements. Did I even look into it? It's just calling the parent, right? As I explained, just it says parent, parent, parent. That's as easy as that is. And then it calls the visitor, same pattern, same contract. Dependencies, really, dependencies are an integral part of the Flutter framework, which is also why I appreciate the provider package so much, because I think the provider package is one of these packages that actually understands how the framework works. Remy really went in depth and understood how the framework works, and then worked with that. And that's really what I appreciate about it. And this is just debugging and diagnostics. Mark needs rebuild is actually Mark needs build is actually really interesting, because this Mark needs build is something that I want to talk about. What it does is pretty obvious. If we take a look here, we can have our elements context as element. And if we call Mark needs build now, what would you expect? Would you expect it to be called an infinite number of times now? Wait, I should probably print something. What could I print? It's not. It's called once. Why is it called once? Because Mark needs build here doesn't do anything, because we're in the process of building, and then marking that we need a build, it cannot possibly do something because we are already building, right? We are building. So we don't need to mark it again. If we delayed this, right? for example, by a second, which is way too much, of course, but it just makes the logs more beautiful. If we delayed this instead, we would now see it every second, because we mark that our element needs a build, and then then it will be rebuilt. The only reason it didn't do this before, printing all the time, was because we were already building when calling it. And this is also why you cannot call setState in the build method, because it wouldn't do anything. You're already, right? It doesn't do anything. Why would you call markNeedsBuild in the build method? It cannot possibly do anything, which is also why in a state, what setState does is pretty funny. Most people are definitely not aware of this. setState doesn't do anything. This is just some debugging stuff that's definitely not necessary. What it really does is it just calls markNeedsBuild. markNeedsBuild. It doesn't do anything else. All of this is just debugging. So the void callback actually does not serve a purpose. The only purpose it serves is that, it does not serve any purpose. Okay, so it's really smart. It's a really smart design pattern, because by passing a callback, people are tricked into thinking that whatever they're doing in there must change something about the state, and this makes people write better code. It makes them not call markNeedsBuild for no reason. And this is what I think is really nice. markNeedsBuild only marks that a build is needed. So rebuild, as it says, is only called by the build owner. We could try to call it. I'm actually not sure what would happen if we call it here. Yeah, it doesn't allow us to do it. If we, what would happen if we did it here? We can obviously also just pass it. Yeah, it doesn't rebuild because only the build owner can do it. But anyway, the important one for us is markNeedsBuild. The same way we don't call paint in a render object. Instead, we call markNeedsPaint, or we don't call layout, etc. And then again, perform rebuild is just, it's abstract. So rebuild itself, it doesn't do anything, right? It's just for diagnostics or for debugging. And perform rebuild is what actually needs to be implemented. For example, let's see what a render object element does with perform rebuild. This will give us some insights. We look into a render object element. Where do we have it? Perform rebuild. What it does is it updates the render object. And that's it. And one thing we can actually still look at is the root render object element. We have the root render object widget. Is there anything special about this? Yes, they have their owner set explicitly. So this has an assign owner, which is really interesting because this means that a root render object element is the entry point to a Flutter app. Let's take a look at run app. What do we have? We have a schedule attach root widget. What does it do? It creates a render object. Wait, attached to render tree. And this is not as readable. I will just search for the readable version of this. Okay, so the readable version of this can be found in Flutter/Flutter, in the examples, in the layers, and I think in the rendering layer. For example, we have a hello world. What do? We have the rendering Flutter binding. Okay. Wait, let's see again. Render position box. Okay. Maybe we'll actually find it here. Let's see it again. We have the render object to widget adapter, which creates a render object to widget element, which extends the root render object element. Okay, here we go. So as we can see, the root render object element will be the root element actually. So the root element is a render object element because obviously we need to have one canvas, and this also explains if the root render object, like we need a render object at the root because this paints everything, right? This also means that we have only one canvas because the canvas in the root render object will paint everything, and it is only passed on to the child render objects. They will use the same canvas, and that's the beauty of it. Okay, so this really was a thing. Let's see where it's constructed. Exactly, in the render object to widget element, and let's see where the build owner is set to get a glimpse at that. So we have the adapter, and we attach to the render tree where we have the build owner, and the build owner here is the one in the widgets binding, and that build owner, wait, let's go back. So we set the here we go. We attach it, and where do we set the render object? Anyway, it's one canvas. It's pretty obvious if you think about it. Okay, let's go back to square one. Let's split this. This is where we started. This is where everything began. And now, as a one last thing, I want to do just a few things with the demo. Let's see if I remember the stuff that I talked about. So we have this example tree, material app, experimentation widget, column, text, 1, 2. Let's see if we can get to 1 and 2. What would we need to do? So we want to have our element, as I said. I had it set up previously. And then we want to visit our children. And now we have the child elements. In this case, it will be a column. So we will only visit the column. But as we know, in this column, we want to visit the children again. And now we have the texts. So for both of them, we want to print elements.widget, as text dot data, and this should print 1, 2. There we go. We have 1, 2 in the console. So that worked. Can we do some more shenanigans? Yeah, I mean, whatever. I think it's pretty obvious. The build context is an interface to the element, and you can do everything with the element because it manages the whole tree is elements. And then also it's just a beautiful design pattern where the whole element tree is obviously managed by this, like the life cycle is managed, like you don't need to manage any of it. It's obviously managed for you completely. And even if you create render objects, you don't have to worry about it because the implementations are already there. And I think it's just really beautifully done. Some stuff, obviously, I'm like, okay, why would you do this instead of doing it a bit differently or whatever? But I can definitely understand why decisions were made, and I can appreciate a lot of them. And I hope that I was able to show, to at least give some insights into how it all works. It was probably really rough, and it was not a good explanation at all. And I actually doubt that anyone watched through the whole thing. Why would you do that, right? It's a whole ramble. However, it was really interesting. It was a pleasure. And remember, you can learn anything, creative creator or maybe not, out.